Hey guys, welcome to the second part of U substitution, and let me go ahead and proceed with the fourth example. So in this example, we have a square root again, but notice that now it's a square root in the bottom. So before I begin, let me go ahead and rewrite this integral x and then 3x squared plus 4 raised to the negative 1/2 power dx. Now, now that'll make things a lot more easier so that when I integrate, I don't have to deal with half power as positive or square roots. Now, let me go ahead and begin our u sub. So u sub, let u equal 3x squared plus 4. And then differentiate with respect to x. Du dx is equal to 6x. And that means that du is equal to 6x dx, but then you notice that you only have an x dx in your problem, x dx. So divide the 6 and you get du over 6 is equal to x dx. Now I can make my substitutions, u and du. So let's go ahead and rewrite this. The integral of u to the negative 1/2 and then times du times 1/6. Now we can integrate this, so it's 1/6. The integral of u to the negative half, if you add 1, it becomes a positive 1/2 over positive 1/2, which will make this into a times 2u to the 1/2 power plus c. 2 and 6 will make a 1/3 u to the half plus c. Replacing u would be 1/3 3x squared plus 4 to the 1/2 plus c, or if it's multiple choice, the square root of 3x squared plus 4 over 3 plus c. And you can do the check on your own for this one. Now we have the trig functions here. So the trig functions, how do we deal with these trig functions? Okay, now we know if this was a simple integral, cosine of x dx would be sine x plus c. Why? Because the derivative of sine gives you cosine. The derivative of plus c gives you a plus 0, which isn't there. But how do we deal with a cosine 3x? It's still the same thing. So what I'm about to show you is not going to change. We're still using the same process. Simply let u equal 3x. Du over dx is 3. Du is 3 dx, but do you see a 3 anywhere in your problem besides the 3x inside the cosine? You can't touch that part. I don't see a 3 in the front. I don't see a 3 in the back. All I see is a dx, so I'm going to solve for dx. So du over 3 is equal to dx. Now I can use substitutions and rewrite this whole integral as the integral of 1/3 du and then cosine u. Now notice I didn't replace this whole thing with a u. I only replaced the 3x with a u because that is the statement that I made here. Let u equal 3x. So let's go ahead and integrate cosine u. Cosine u is now sine u plus c and then the 1/3. And then here's the easiest part. 1/3 sine 3x plus c. And this is your answer. Let's do the check for this one. Let's check it just to make sure. The check, for any time that you're using u substitution, you're always going to have to use chain rule to do the check when you're taking the derivative. Otherwise, we wouldn't be doing this lesson. So let's go ahead and check. Let's take the derivative of sine of 3x multiplied by 1/3 and then plus c. So the derivative of sine is cosine 3x. times 3 times the 1/3 that was originally there, and then the derivative of plus c is plus 0. 3's goes away, and we have cosine 3x. So yes, this does work out. Here's the next part. Example number, I think this might be 5 or 6. Fifth example here. Let me erase this. So now we have a secant squared of x cubed. And notice here's an x squared, here's an x cubed. So this tells you to choose u to be x cubed. So that du is equal to 3x squared dx. And then you don't have a 3 in your problem here, so I'm going to divide both sides by 3. So du over 3 is equal to x squared dx. I did skip a step. I'll let you guys make that assumption. I'll let you guys figure that out. So here's my dx, x squared. Okay, and here's my u. So let's go ahead and rewrite this integral as the integral of 1/3 times secant squared u du. Now you have to go, now the antiderivative of secant squared u, you have to remember what function's derivative gives you secant squared x. And then you know that it's tangent x. So it's 1/3 tangent x plus c. Oops, not x anymore, u. And then we replace u in here, so it's 1/3 tangent x cubed plus c. Let's do the check. 1/3 tangent, not squared, sorry, tangent x cubed plus c. Take the derivative of tangent is secant squared. Keep the inside, take the derivative of the inside, multiply it to the outside, it's going to be 3x squared. And then plus 0, of course. 3's goes away, and you get x squared, secant squared x cubed. That was pretty simple. Okay, so now in the next problem, notice this next problem is going to be a little bit more difficult. Sine cube of 5x times cosine 5x. What I used to tell my students last year and the years before, if finding the u is not super obvious, then do a trial and error. For example, I can choose from sine cube of 5x or cosine 5x. Let's see which one could it be. Let u equal sine cube of 5x. The derivative of sine cube of 5x is 3 sine squared 5x, and then it's times cosine 5x times 5. I'm doing the chain rule. It's a triple chain rule. This is the peanut chain rule that we've discussed before. Now notice, I have way too much information here. I have a cube, here I have a squared. So no, this is not going to work out. Let's try the other part. Cosine 5x. Let u equal cosine 5x, so my du dx is negative sine 5x times 5. But I have a problem here. This sign doesn't have a power, but this sign does. It has a 3. It has to match. So I can't use cosine 5x. It seems like I've used all my options, but then you have to remember from pre-cal that the sine cube is the same thing as the sine quantity cube. So whatever the sign is, you can put parentheses all around it and then cube it, and then cosine 5x. Now we have another option, a hidden option that you can see that wasn't so obvious. So let's go ahead and try this. Let u equal sine 5x. Du dx is cosine 5x times 5. And I do have a cosine. Let me go ahead and just solve for du. 5 cosine 5x dx. And it seems like I do have a cosine 5x. and a dx, they're right there. The 5 is extra, but we know that if it's a constant, it's no biggie. So let's go ahead and divide it out. Cosine 5x dx. Now we can go ahead and rewrite this integral as 1/5 du. What do we let u equal? We let u equal sine 5x. What is sine 5x being raised to? The third power. So it's going to be u to the third. Now we can integrate u to the third, and that becomes u to the fourth over 4 plus c, so that my final answer is the sine of 5x raised to the fourth all over 20 plus c, or the sine to the fourth of 5x over 20 plus c. Those two are my answers. And then I'll let you guys make the check. You have to really know your chain rule to check this problem out. So I only have my last problem, and then I'll go ahead and end the video. Here, okay, so now we have an x cosine to the fourth of x squared sine x squared. Okay, so why don't we just rewrite it? It doesn't hurt just to rewrite this. Let me go ahead and do another pair of parentheses here. Okay, so let's think. What should we let our u equal? If we let u equal sine, I will get a cosine, but not a cosine to the fourth. Okay, and we cannot let u equal x. Letting u equal x, its du will not produce any trig. So the only option for me here is to let u equal cosine x squared, so that my du is negative sine x squared, and then the chain rule 2x. So let me clean this up. Du is equal to negative 2x sine x squared dx. I don't have a negative 2 in my original problem. I do have a sine squared x and an x. So you got to be very careful. They'll mix up the terms on purpose. So what do I have to do? I have to divide both sides by a negative 2. So divide by negative 2, divide by negative 2. So I get negative half du is equal to x sine x squared dx. Here's my u. Here's my du. Let's proceed with the integral. So it's the integral times the negative half of u. Here's my u, which is being raised to the fourth, and then du. U to the fifth over 5 plus c, and that is negative 1 over 10 times cosine to the fourth of x squared plus c. This one I will provide a check for you. So let's go ahead and do the check. This is your answer right here. So make sure you have that boxed. I'm going to rewrite this like this, and then let's do our check. So taking the derivative of cosine x squared to the fourth, drop the 4, negative 4 over 10 cosine x squared to the third. Taking the derivative of the inside becomes a sine x squared, and then again chain rule, this is the peanut, times 2x, and then plus c just becomes plus c. Now notice look what happens here. We get 4 times 2. So give me a second here. Okay, excuse me guys, I did something wrong. So I did a copy error here. So this is supposed to be 5. That's supposed to be 5. So this should fix whatever I saw that was wrong. 5, that becomes a 4, that is a 5. And here we go, let's proceed. And then notice that a 2 times a 5 gives you a 10, and I forgot that sine is a minus when you take the derivative of cosine. So now you have a negative times a negative, which is a positive. You have that cancel, so you have a cosine x squared raised to the fourth sine x squared, and then of course times x. And there's my final answer, which is the same as my integrand in this problem. Okay, so there's the U sub. Hopefully you guys enjoyed it, and it just takes some practice to actually learn these problems. The last two problems are like the advanced U subs, but with practice, nothing's impossible. So I'll see you guys in class.